Pijaga or Sarcastic CJ, and welcome back to Curious Contrarian. Man, I love doing these episodes. Today, we are going to actually look at one of my favorite things in philosophy, the scientific method. So, before starting with what the scientific method is, we should, I guess, know what exactly is science at the first place. Well, let's take the definition for that. So, science is a methodical approach. I think I pronounced it right. A methodical approach to study the natural and the social world. It asks basic questions such as how does the world work? How did the world come into existence? What was the world in the past? What it is like now, and what will it be in the future? And these questions are generally what they are answered with the help of observations and experiments. So science attempts to bring certain facts under general laws. The main aim of the how to reach the main aim of the scientific method is through empirical reasoning, that is induction, and through formal reasoning, that is deduction. So in this, I'm going to make this into a three-parter or a four-parter maybe. So first we need to know what is induction. So induction is a process from which we draw basic general laws or conclusions with the help of observations and experiments based on finding particular facts. So if a particular fact is found, from that fact we make a general law. So experiences furnish us with general facts and not with general truths. So in order to find general truths, we need to connect those general facts and make it into a thing. It makes sense, I guess. For example, if I take a premise like Chinmay is mortal, Kanishk is mortal, and Arman is mortal, so I can make out a conclusion: all men are mortal. Even though it doesn't, I haven't included every single male in this premise. I can just draw the conclusion out of these three facts. We know that I am mortal, Kanishk is mortal, and Arman is going to be mortal, so all men are mortal. That is basically induction. The formal grounds of induction include two laws, and the first, or one of them, is the law of uniformity of nature, or basically anything in nature repeats itself. Anything in nature, understand it, if it's artificial, it might or might not, possibly it would repeat itself once. That's my opinion, but that's what nature does, if you get the point. So let's see what the definition of the law of uniformity of nature is. So the law of uniformity of nature is a fundamental principle in science that suggests the laws of nature remain consistent over time and place. So basically what we are talking about here is that the law of gravity, for example, the theory of gravity, the three laws of gravity of Newton is going to the three laws of gravity proposed by Newton is going to be applied either I am living in India, or I am living in Germany, or I am living in the US. Doesn't matter, the law of gravity is going to be applied on me. You can't change that law, it's going to happen. So it is based on the idea that nature is based on a uniform manner, and is used to make hypotheses based in many areas of the science which we are working on. So the principle is tested and validated through countless experiments and observations obviously, because without experiments and observations you're not doing science. If you're taking anything on face value without proving it, then that's not science. As a law of causation, so law of causation basically, as John Stuart Mill said, that everything has a cause. So I mean, any matter has a cause. So the law of causation is, read its definition. So the law of causation is a fundamental principle that states every event has one or more causes leading to its occurrence. It's a crucial concept in many scientific and philosophical theories, and helps establish a logical and predictable relationship between cause and effect. So understanding this principle can make us how can you say, it makes us, or it can help us in making informed decisions about some particular discipline of science. For example, some event being occurred in the field of physics, chemistry, biology, geography, etc., psychology, sociology, any science you want, can have a relationship between each other. For example, let's take a geographic example. An earthquake happened, so there has to be a cause to that earthquake, why that earthquake was caused, and what was the effect of that cause. The cause of the earthquake was the collision of the tectonic plates, or the movement of tectonic plates, a rigid movement of tectonic plates, and its effect was the building breaking. It's just the building falling down, not breaking, the building falling down. That was its effect. But if we go deep into it, what was the cause of the tectonic plates shaking? So that's how you can create relationships in the particular discipline to find or to know more about what you are working on at that point. So there are two methods of induction: observation and experimentation, or experiments, observation and experimenting. So let's take a look at the observation and its definition. So there are two methods, methodological or methodical grounds of induction, and I think that's the major part of sciences. Without observation and experimentation, I think I wouldn't call it a science. So observation, literally, let's see what its definition is. Observation literally means keeping something before the mind, and should be distinguished from careless perception. So it involves perception without any purpose. We need to have unbiased mind, as unbiased as possible, because you can't have a properly unbiased mind. So we need to have as unbiased mind as possible while observing something, because we don't need to find any purpose in that perception. Because generally the thing is, humans tend to find purpose where there isn't any purpose, because our evolution has sadly made us into such pattern seekers that we see that a cloud formation looks like the map of Britain, looks like an angel, looks like Godzilla, or whatever. Now let's go to experimentation. Experimentation is an artificial reproduction of an observation. So basically, let's check its definition for once. Experiment is as an artificial reproduction of events under controlled conditions, pre-arranged and selected by ourselves. So scientists manipulate certain facts and facts in certain ways for certain conclusions. So if I would turn the pressure down to this, how about what would happen then? If I turn the pressure high, how would that happen then? If I turn the temperature low, what would happen at that situation? Something like that, if you understand that. So thus we infer that thus we have to interfere with nature in order to draw conclusions out of what we are thinking about. So if so I think the best method is to first observe something. I suppose I observe some development, and I try to reproduce that in my laboratory, and if I manage to do that, I can draw out some facts, make a theory out of it, and state it with my with the thing I have proven with my experimentation. So just as adding by ending this fantastic episode, there is actually very misconception between a lot of people regarding theories. So there are two types of theories. There is one theory which we generally know as an English vocabulary, something that we just fantasize, like, okay, this is my theory, maybe this happened, right, without any evidence. Whereas a scientific theory is something that like in science, getting the word theory in front of your hypothesis is one of the most respectable things you could actually get in the field of science. Just saying that, look, this has been thoroughly tested, we are we're mostly certain that this happened, and this is with our general law. I just have to say that because a lot of apologists state that evolution is just a theory, but it's a scientific theory and it is thoroughly proven, so it's true. Sorry to say, but you can't change it, it's true. Another reason why science doesn't make it a permanent fact, because science doesn't want anything to be dogmatic. We don't want to be like, okay, what Darwin gave the theory with his proof, that's it, don't question it. Unless we don't question it and try to prove it ourselves or find some loopholes in it, okay, like he explained us this, but he gave us the theory of natural selection, but that doesn't mean something of genetics, because I think Darwin came up with a theory when DNA wasn't discovered. So you question that theory, you try to prove it, you change some certain facts, and from those you you refine that theory. Because technically right now I can surely say that what theory Darwin really had, and in his time, we know, we as a layman, I can say I know evolution much better than Darwin, because there has been so much advance in that field that Darwin would have never even thought about it. Similar to Einstein. Einstein gave the theory of relativity, and right now if you would pick any physics grad or any normal astrophysicist, any astrophysicist, not normal, any astrophysicist, anyone with who is studying astrophysics, he would know the theory of relativity much better than how Einstein knew it. This literally is not demeaning what Einstein says, because after Einstein gave that theory, we have developed that theory like so unimaginable what Einstein could have even thought about it, because he gave us a field where scientists worked on, and we refined that theory. And that doesn't mean that we are rejecting the theory of relativity itself. We are using